Well, hello, good day, good afternoon. It's an honor for me to introduce you, Engineer Marcial Rivera Rodriguez. Today, we're going to have a webinar, and the webinar is Developing Integrated Guidelines for Post-Disaster Infrastructure Assessment, a collaborative approach. So, first of all, thanks, Marcial, for the webinar that you are going to give us. And let me introduce you, Marcial. So Marcial is a construction engineer, um, graduated from the Costa Rica Institute of Technology. He holds a master's degree in disaster risk management and emergency response from the University of Costa Rica. He is also a specialist in statistics and a specialist in business big data, both from the Costa Rica Institute of Technology. He has worked for more than 18 years at the Federal Association of Engineers and Architects of Costa Rica, where he currently heads the Research and Analysis Department. He serves as representative as well to the National Statistical System and the National Emergency Commission. At the international level, he represents our association as Vice President of the Digital Transformation Committee of the International Federation of Consulting Engineers, FIDIC. He also served as secretary of the Disaster Risk and Climate Change Committee of the Pan American Union of Engineers Associations. And he is a member of the Disaster Risk Management Committee of the World Federation of Engineering Organizations. His professional career has focused on data interpretation and management. He is a graduate level professor in the damage assessment course and also served as a facilitator in data and Power BI training courses. So let's give you, Marcial, the stage, and let's begin with the webinar. And thank you in advance for the webinar that you're going to give us.
Thank you very much, Daniel, and I'm very pleased to say hello to people all around the world. Good afternoon, good day, good night. And what do we expect to have today? Today we want to tell you about one experience that we have in Costa Rica developing a guide to be used when we have an earthquake. That's the way it began. We had the necessity to cover how the house were inspected, but a group was made to do that. And when we start working, that this is maybe like 8 years ago that we started doing that, and we realized that not only earthquake was important to be considered. So I want to include or to tell you about all the things in this experience that we have. It was made with international collaboration from in that time from BHA, the Bureau of Human Assistance of the United States of America, was the country who made that through Miyamoto International. That is the company who developed that project, and then it gathered some engineers from Costa Rica from different institutions that we are going to talk on this time. So why do we have to talk about disasters? Let's start first. What is Costa Rica for all of you who may not know where we are in this big continent of America? Let me try to put the laser. This whole continent, Costa Rica, is a very small country in the Central America, has a population of 5 million people and an area of 51,000 square kilometers. So it's a very small country compared to many others. And the organization where I work, CEFIA, Colegio Federado de Ingenieros y Arquitectos, is the Association of Engineers and Architects of Costa Rica. It's a professional body that oversees engineers and architecture practices in Costa Rica. So we are also responsible for the drafting, updating, and publishing of the Costa Rican Seismic Code, and that is why we also are involved in the national security system. We are also involved in many things because as an organization, we are the one who produced the code. the seismic code in our country in union with different universities. So I when I start this talking, I like seeing one number. It's not from Costa Rica, it's from Mexico, but I think that it helps to understand how important it could be. When Mexico had the earthquake in 2017, the one that it was a really big one earthquake, 600 buildings from 2,006,000 buildings were damaged. Only the 0.023% of the buildings were damaged. That means that the structural risk is not the most important, but when it happens, it produces damage. Normally, the non-structural risks are more important, and sometimes the not the damage, the injuries that it can produce on people are more important than the damage or the injuries produced from structural risks. The non-structural risks are more important. And I want to illustrate this with some videos from earthquakes that happen in our country. This first that I want to show you was in 2012. On September 5, there was an earthquake in the morning at 7.6. That was like one of the biggest earthquakes on Earth that year. And I want you to see how you can see all the parts of the earthquake. Sorry, because it. Okay, there you go. It was in the morning. Many people were at work or were at home. It was very early, 8:30. And this video is made like 150 kilometers from the epicenter. So as you can see the arrivals of the waves, you can see the S wave arriving, the P waves arriving because there was enough time between all the different waves to arrive. Then the L and the W, the third waves were is also seen because of the distance that is the earthquake. So as you can see, the building did not collapse. There are no walls that collapsed. The roof did not collapse. All the damage is from non-structural elements, mainly from all the groceries that are in the stores that may produce some damage on people that are using the infrastructure. Let me see, because it got stuck and I can move to the next thing that I need to see. Okay. This is the same earthquakes seen in a building, in an office building, a court in Punta Arenas. This is main city, almost like 50 kilometers from the epicenter. As you can see, the building did have some damage, not that it needed to be turned down, but the main problem are all the artifacts that we put inside the building, and that people may have risk from getting out from the building, from the evacuation process, because it was not controlled. People acted under the natural scare of being on a very big earthquake. I don't remember if I said, but it was a 7.6 earthquake. So even that those experiences are in a commercial store and in a building, and this topic is about housing, I also want to share an example from another earthquake. This was in 2009, almost 17 years ago. It was on 6.4, but this house was very close from the epicenter of the earthquake. And as you can see, the house did not, the walls did not fall down, the roof did not fall down, the floor was okay, but all the glasses that fall down and all the housing that element that fall down may produce a risk for people who need to run in this area or to need to walk around this because of the earthquake. So there are many elements, there are many aspects in a house that has to be considered in order to give a secure uh, procedure and also a secure assessment of what happened on all the infrastructure that we have seen. So we propose to have an standardized forms for the rapid structural assessment of building residential buildings, and it was a project made by Prepare project. This is the project that was developed in all America, uh, financed by DHA, the USAID office in Latin America. All the information that I'm giving to you is published by the Ministry of Housing. The guide, the booklet of how it should be filled up is public information that you can see on web page. I put the link there that you can also see it at the end. Particularly the guide to be used and how to fill up the information that we are going to see. Okay, so what was the need that we uh, see at the first? We need to assess infrastructure after an emergency, not only an earthquake. It was the main point that joined us. That is why I showed you the videos of why earthquakes are important in Costa Rica. But also, this is another example of a wind blow that damaged a school infrastructure in the south region of our country. So we have the need of assess infrastructure. We have the need of collect essential data for institutions and agencies. We need to coordinate efforts among multiple entities, also including the volunteers. And we need to generate actionable results for decision making. So for example, if the country needs to ask for help from another country, we first need to know how many houses or how many people are injured. So gathering all the information in the shortest time is a very big issue when we are planning to attend an emergency. So those were our needs. But there was a reality that were happening in our country in those earthquakes that I told you in 2012 and in 29. Sometimes multiple site visits were required. Why? Because some people gather some information about the housing, the technical information. For example, there's a crack in the wall or there's a window that is broken or something like that, but they didn't gather all the information about the family. And sometimes it is needed. So we found that we have non-standardized information. Also, this different visits and this non-standardized information can generate high costs because sometimes people have to go to make twice or three visits to a house. So it doubles or triple the cost of having these inspections. And also, there's damage affecting both housing and surrounding environment. So sometimes you can say this house has no damage, the house is okay, so it has no problem, but there's no water or there's no access. So sometimes the people are saying, okay, you don't need any help. But the people say, but I can go to the house because I don't have water. So even that the house has no damage, all the surrounding elements are also important to be taken because sometimes the limitation of using a house do not only comes from what happened to the house, but also what happened to to the environment or hazard that happened around. So all this information was something that we were not gathering on the information. We also have some challenges on this. For example, in Costa Rica, there's something very interesting about the property ownership status. If someone rents a house and the house is damaged, one institution gives help to that people. But if the family is owner of that house, is a different institution that it helps. So something that may be not so important for an engineer, for example, saying what is the status ownership of the property, it becomes very important for the agency that are going to help the families. So it becomes very, very important to have a list of data that describes how the family is composed. For example, if there are children under age, if there are elderly people in the house, and all these elements were also important to include. Also, as challenge when we are doing this is the limited access. We have discovered in Costa Rica, and maybe it happens in other countries, there is something that we call disaster tourism. There's people that want to go to see what happened. They want to see what is going on, what happened to a wall, what happened to a bridge, what happened to the river, and people want to go to see, but then necessarily want to help in that moment. So we have to separate people who can help in one moment and people who want to see what happened. Uh, I think that we didn't mention, but I have just remember, please use the chat if you have any questions. You can go right in your questions. If I see it, I can answer immediately, or maybe we can put it at the end of our session. So please feel free to use the box of questions and let there all the questions that you have. Okay, we have limited access. We have also some uncertainty about completed inspection. Also, we don't know if the house was complete seen, if we have all the information, and also there's a diversity of damaged infrastructure. For example, as I was saying, we may want to focus on housing and see what happened to the house, but maybe if the water tank has suffered some damage from the earthquake, it's also important to know that that happened, even that we can't handle that information with the form. We also need to gather the information to know that there's different damage infrastructure. A bridge can be damaged, a water tank, electricity, wiring, etc. There are many, many things that can be damaged. So this is also a challenge where we are trying to gather all the information in just one form. So we have to recognize that we have some scope and limitation, and when we start working, we started working under these parameters. We do not want to prescribe corrective actions. So if we go to a house and we see that something is broken, we are not going to say how to repair it. It may be easy to say, like, okay, you can put a stick to hold the wall in it to be a damage, but we can't work on that because we have to assess very fast all the more quantity of houses that we can. So we are not trying to work on give actions to correct what happened. We also know that rapid inspection, rapid assessment may require follow-up evaluation, and this is something that is inside the form of the assessment. We know that when we go, we may say this wall has a crack. I'm not completely sure if it's damaged all the housing or not. I need maybe a bigger a detailed inspection. We're going to see this in some minutes. So the difference that to recognize that there may be needed some follow-up evaluations is also inside the form that we are where we gather information. And one of the conclusion of our inspection could be, okay, we need some more inspection, and especially when we talk about, for example, um, the soil, mountains around, trees that are around maybe it's not our expertise, and we need some geologist who can add some information. It's also, we recognize whether we are only going to work on housing and structure. We are not going to deal with schools or with health centers or with bridges because it needs some different approach and technical approach. So we decided to focus on building and housing structure only for an only 2-story building. in our country, the most of the housing are individual housing. We have not so many double houses or apartment buildings. The most of the housing are individual. So this guide we propose the form to pick up the information is only two buildings from 2 stories, and also we limit it to areas under 250 square meters. This also the scope and limitation are the scope and limitation that our seismic code has for simplified design. We have a chapter in our code 6 that says that if we have a house with certain characteristic, not more than 2-story building, and also areas under 250, you can use an standardized design. You don't have to calculate individually that house. So we also use this as a limitation for our form that we were developing. How did we approach to this? We decided to make a group collaboration, also using the international cooperation that finance was the founder of this project. We use a Ministry of Housing document that they previously used to pick up information from the housing. So we use it as a base. We also decided to use the ATC 20 from New Zealand Field Guide that is for post-event building evaluation. It helped us a lot to have some information about how to make the guide. And we also decided to include emergency scenarios that are commonly observed in our country. So even that this started as an earthquake project because the international cooperation was an specialist structural engineer, we decided that in order to be used in our country, we needed to include also flooding. We need to use all the other rest of emergency that we have from the position of our country in the world. Those are the institution and agency that participate in this project. The Ministry of Housing and Human Settlements, that is the Ministry of Housing, the municipality of San Jose, that is the local government of the capital city, also the School of Civil Engineers of the University of Costa Rica. We at the SEFIA, I was participating from the Association of Engineers and Architects. Miyamoto International is the global structure and seismic engineer firms that help us, that was guiding in this project, and also the National Laboratory of Materials and Structure Models from the University of Costa Rica, who also provides an engineer who help us in this project. So at this point, when we decided what we are going to do, what were our challenges, where was our limitation in our scope, we have to recognize that there are some different types of assessment. There's a rapid assessment that it should take like 10 to 30 minutes to be made in one house, and it can be conducted by professional training the students or qualified personnel. For example, the kind of qualified personnel are municipality inspectors, are some that can be trained to do this, and in our country we train them to do this kind of inspection. And this guide is about this rapid assessment. But there's also detailed assessment. It normally can take from 1 to 4 hours, and it can only be conducted by engineers or engineer professional or specialists. This is something, for example, when you said, I'm not sure if this wall can resist, so I need to make some more tests or something else. And also there's an engineer assessment that what it looks is to give the solution. The first two, the rapid assessment and the detailed assessment, they look to give us information about and decide what to do. When you do an engineer assessment, normally it's performed by a licensed engineer contracted by the property owner to give a result, to say, okay, you have to repair this wall with this kind of a structure. You have to repair the roof with this kind of metal. You have to do that with this material. So there's a solution given from the engineer assessment. So those are not the points where we are to focus. Just remember, we're focused in the rapid assessment. Okay, what is the rapid housing assessment objectives? What we are looking for is to identify risk of total or partial collapse. So the first thing is the house is collapsed. We are not going to develop all the rest of 20 items, because if you know that the house collapsed, the list says, okay, the house is collapsed, done. I know that the house has no repairment and the house did collapse at all. Also to detect hazard from non-structural elements inside the house. Sometimes the windows or sometimes other elements are also in risk, and not only the walls or the columns or the pillars of the are the ones who may give a risk. Or there are also things like lighting, ceiling, and others that can also be a risk, but not on the same level as structural. But as I said in the first part, non-structural risks are very important also to be taken care. We also have to assess whether damage poses risk to adjacent structure or terrain. Sometimes the house is the one that is provoking the risk to other structure. Sometimes, for example, if the house has a sewage and it was damaged, the house can provide a risk to the rest of the structure. So we also have to see if the house is receiving risks from the surrounding, or the house is provoking the risk. We also have to identify external hazard, as I said. Um, First, and also public safety hazard from contamination, the point that I said also, and also create a damage inventory to support decision making. So if we have a list, if we know exactly what is happening, if we know what is the part of the country where more houses were damaged, or if we know something else, we can focus when we have to take decision in the main city or decide in the decision making place. We can know where are the first places that we need to go, or is where more money is going to be needed, or where more shelter is going to be needed if more houses were damaged. All this is information that has to be uh, quickly taken as a for decision making. We also decide that there's a workflow, and this is something that were developed after in the project. The project take almost like 6 years to be taken completely, with all the parts, also including the training course for people who has to do the assessment. So we decided that there's a preliminary registration that is the municipality emergency committee that has to do it, and that's saying this house needs to be inspected, that house needs to be inspected. So it's the first list where we know where are the points that an engineer has to go to see. Then comes the rapid assessment. This is something that has to be coordinated with the National Emergency Commission. So that means that one engineer do not go to one place because he wants to go, because we come to the point that we said before, the disaster tourism. You have to go where you are asked to go for, because the decision making has to decide where are the places that are safe, where are the places where the people that go has a shelter where staying, where they're making the inspection, if there's water, for example, or if there's food for them during the day. So we also need, this is why it has to be coordinated, because we have to go in the places that are safe to go. And just remember that when there's an emergency, always the first emergency responder are the one who goes when places are not safe, to try to turn them safe. If there's a fire, they have to try to turn it off. There's some water flow, they have to shut down, etc. When that first part is completed and is more safe to go, is when we can do the rapid assessment. That is what the coordination is very important. And also there's a follow-up when we know that a house has been damaged. The responsible institution or the agency who has to give the money, have to give the support, is the one who has to follow up. It's not a mission of the engineer, it's not a mission of the architect who goes, it's not a mission of the committee of emergency. If they have to receive money because they were renting the house, then the institution that give the helps is the one who has to follow up what happens with the information that was gathered by the engineer. When we're looking how to do this, it was very interesting because we have to search around different forms. gadget that we can use, Google Forms, Microsoft Forms, uh, etc. The number is very, very big. And there was some limitation on the most public because they don't gather the geolocation. Because for security concern, they don't gather the point where the um, form is filled up. But we needed that. That was something that to us was very, very important. So we need that information. So we have to explore which were the apps um, that could help us with this. Um, For example, Kobo Toolbox was like the big surprise. I recommend you to search on this. Kobo Toolbox is geolocation tool. Is an form tool with geolocation that can be programmed. It's not only like a simple question. If you learn about to use this tool, you can program very complex questions. If you do this, then go to this, etc. And it's supported by many international and used by many international uh, agencies. And I think that we all have to give one opportunity to Kobo Toolbox to know how to use it. There's also some like RGs, Survive 123 or GeoTDK. There's some others, but some of them may be paid. And for example, Kobo Toolbox has been planned to has a free use and also has an emergency scalable so that when there's an emergency and many answers are given in some time, they have more flexibility to receive a lot of questions in just one time. That sometimes maybe it requires a payment to do that, but it's important to know that um, there also exists this opportunity. And Nick Sigurus, your question, I think that I'm going to cover in a while, but I will return if I miss something of what you said. So I think we're arriving there. We also make a procedure. It's in Spanish, so most of the picture that you're going to see that are from the guide or are from the book or are from the form, I have not translated because it's from the original tool. So we have a procedure that guides the people who make this inspection how to do it. Is also included in the training course that all of the inspector have to take before going to field. And um, I think one of the most important things is tagging because we we give a parameter to each of the items that are evaluated. We give a number to any point to each point, and at the end of the evaluation, it gives a result that tell us if we have to say that the damage is severe, is moderate, or is light or none. And we can stamp on each house. We can tag what is the condition so that also people knows if they can't use the house, they may have some restricted access because there's a risk, but not so big, or if the house is safe and people can return to the house. So we use the traffic light standard coding for colors like to use. There's also, I have been saying, even that earthquake may be the principal element that we have, we also included flood, landslide, avalanche, fire, and also volcanic eruption, hurricane, and tornado. Sometimes the damage that can happen from this, from any of this, can be also evaluated with a structural damage. Let me see an example. If there's a landslide and a rock collides with a wall, the damage that you are going to see may be similar to the one that an earthquake can produce. In a flood, maybe there's no damage when the house is from bricks, but maybe the electricity part or other elements can be damaged. Also, the sewage are very damaged when we have flood. With fire, sometimes the metal elements that are exposed to high temperatures can be suffer damage similar that what happened when an earthquake. So we know that even that the tool is mainly thought on earthquake, and many of the items are thought on earthquakes. We use them to evaluate also some other kind of events that can happen in our country. So I think that we go to what Nick asked. So Nick asked, I would like to ask if you need the drawings of the structure and what happens if there are different from the permit drawings, especially in small structures. Okay, when we do an inspection, as an association of engineers and architects, we have the drawing from the house when they are from the last 20 years. We have on digital for the previously we don't have them. So even that we may have some drawings, there's also we have to recognize that the houses may change during life. So for example, there may be a house that has a window. Someone decided to turn it into a door. So even more important than what was in the original drawing, or what was the permit to allow. It's more important to see how is the house being used by now. For example, um, you may have think of an area and then use it to park a car. So the weight the floor has is different from a bedroom if someone changed it. Or um, so we don't have it. It's not so necessary because what we are going to evaluate is what we found in place. And about the materials, that is why we decided to make a characterization and say every single kind of material that we found as a external construction, inner construction. There's masonry, concrete, uh, wood, and there's a list of material. And we also in the book has a description of how to identify this material and how it may look like. This is for people that are not so used. Maybe engineers and architects are using it and it's easy for them to understand. But for some other professional that we also want them to participate, it may help them to find that. We also found what is in the floor, what is in the roof, and how is the cover of the roof. This is the part that I said. There's like this kind of wall. We say, okay, when we construct this, it's seen like that. When it's being building, you see it like that. When we use this kind of labeled of tiles, it's seen like this, it's constructed like this. So we have a description of every single material that we included in this form. And I think that this is one of the, mm, it took us like 2 years to solve this because I think it's one of the most important things that we all can do in our countries. And I will try to explain this. What we decided is, for example, these are cracks in columns. And we say, okay, this has a weight of 3 because it's a very important item to evaluate the house. But there can be non-damage, light damage, moderate, or severe damage. So the number that we have here is the multiplication of this weight with the quantify of the damage. When it's severe, it has a 3, moderate has a 2, light has a 1, and none has 0. So if there are known cracks on columns, the number that will add is 0. But for example, if there's a crack, a grave, severe crack on columns, then the multiplication of 3 by 3 is 9. So the number is already set in the in the form so that we can use the number. Um, I say at the beginning, for example, if the house collapsed, that is this first one, there are no medium size. The house did not collapse or the house collapsed. And for example, it says here, if you choose severe, you don't have to fill up the rest of the information. And the when we do it in Kobo Toolbox, the form is closed. So when you say that is severe, you don't have to fill up more information because it doesn't important if there's a crack in the wall because all the house did collapse. So putting this number was a very long and hard job, and I think that this is something that every one of us can do in our country. And this is I will say it at the end, or I will say this idea more at the end. But I think that is the thing where we can help each other, where the experience from the countries that have developed this, if there's a country that has not developed this kind of evaluation, we can share our experiences and know how we can do this parametrical um, calculation. To know what it means, like light, moderate, or severe, we also put an explanation to the inspector to choose when he has to. For example, when is a crack light when it's smaller than 1 millimeter? When is moderate when the crack is 1 to 3 millimeters? When is severe when it is bigger than 3 millimeters? There are also some other points. For example, if you can see steel reinforcement, you can see it through the wall, then it's severe. So that's not the only point we have as for each one of these element items, we have different things that has to be checked. We also put a picture to help people to understand how it looks like. For example, this is a severe damage in a column, and this is a moderate because it do not it's bigger than 3 millimeters, but it's bigger than 1. We also do the same with non-structural damage. For example, windows falling from doors, that the drain system do not work, the drain sewage system do not works. If there's something with the electrical system or water system or from the roof or ceiling, we have all this point. To each one, we give a weight, and we also give it has a weight from the damage. So people who are filling this up can put the number, choose the number. There's also an evaluation from the external hazards. From, for example, if there's a cracking on the settlement, if there is water that threats the house, and also there's if there's hazard from trees that may fall down, and there's also for all of these there's a number of the weight of this item, and there a weight for how is the damage um, evaluated. When we finish this, we have for example, if you found no damage in the house, this is none. Okay, you check this and you can choose green as a color. If you have a number between 1 and 25, then it's medium, is light, and you can choose it also as green. If you have a moderate, if that means that the number comes from 26 to 68, you choose it yellow, and it comes from 69 to 120, it have to be chosen red. It also we said that if the inspector, by his criteria, feels that, for example, okay, I have a 67, but I think that it should be red, they may change, and they have a space to justify why he thinks or she thinks that the number may not represent what he found, and then the color of the tagging may be changed. Also, there's not one only number. There's not only number. We have a summarize from damage in the houses. We have a summarize from damage in the surrounding that has also the same colors but different scale numbers. We are in the scale of 3, 4 to 16, and the biggest number is 33. This is are these are pictures or the screenshot from the data tool collection. This is what we develop in Kobo Toolbox. The people who take the training, they receive an user because you have to have an user and registered user on the Ministry of Housing. And through your phone, you can download this application. And with this application, you start filling up all the information. It has not all the visual because you are supposed to have written the guide before, so you use it to you use it as a guide to say. All that has this red asterisk mean that is you have to fill up. You can put known or grave or whatever, but you have to choose one. And all the items that we were seeing before are included in this data field collection. And this tool that we developed said, okay, from all the structural that you choose, this is the number. From the non-structural is this number. So the house has an evaluation of that, and we recommend this. But then it proposed to the inspector, you should choose this, but you are free to choose another one from your experience. We also make a list of the equipment and safety items that people who make inspection should make. Those that are the National Emergency System should give the people. The other one that the evaluator, the inspector has to take from himself, for example, a cell phone or the kind of shoes that he has to use. And there are also some optional equipment that we think that it could help to make the inspection, but it's not mandatory. For example, using a hammer or a screw to open or to see elements inside a house. Okay, this is what I told you that where I want to arrive with this. There are many opportunities because the parametrization of the evaluation process is something that we did with housing, but this work and put on weight on what it means and the damage that it has and make this metrics of numbers is something that we can do in many other systems. For example, if we are dealing with agricultural items, we can put what is the item. For example, if there's enough, uh, um, I don't know, rain, or there is not enough rain, how it measures and put a number. And that as professional, we can work on making things that can be used to set automatic tools so people can do more things automatically because that will make faster when we make the evaluations. Also, we have to work on development of data collection systems. All the things that we can fill up in a form means that it doesn't has to be transcribed. Before we did that, we have papers. So we have engineers filling up papers for a whole week in the field. They have to wait, they have to expect that they get to the office the next week. And until the next Monday, they started to put inside a computer the information that they collected 1 week before. And this is time loss when we are talking about emergencies. If we have some information in the Monday, we should start making decision the same Monday, the same day, because we already have that information. So a collection system help us to reduce that time. Also, we have to train the community. It's not only things that the engineers from outside or from the main capital have to do. We have to use all the resources that we have inside. Also, something that is very important from this is that we standardize the results. Is it's not valid that I say, okay, this column is has a severe damage, and other engineers said that no, this is a light damage. We have to standardize the criteria that we use to choose the answers. Also, it will be faster, as I say, and the final thing is that we have to be decision making very fast. That is my information. Uh, but okay, maybe what I want to focus on this is that on this time of the war, when maybe the international help has changed a lot, the biggest country that have helped us sometimes in Africa and Latin America and some other developing countries uh, have changed the way they work with us. Maybe it's time for us ourselves to give support between each other. We, the developing country, we can work together on trying this. And I think that this information that we had can should be shared, should be the experiences, the good experiences, the bad experiences that we have developing this tool may help any other country to reduce the time to have this information, and also to have can make decision faster. So I don't know if you have any other question from this. I can only see the first two that we have. Please, uh, we have also put a survey there's a link survey that we will love you to fill up. We need this to know if we can improve our webinars, and also because we need the information for our participation certificate. So please take a time. You will find it in the chat with the information from the uh, survey about this information. I can see any other question. Let me see. Thank you, Nick. I don't know if I answered your points, but if there's anything else, please let me know. Let me see. I think that I have a question. Okay, I think I have a new one. Okay, Nick, you're welcome. Okay. If not, please pay attention. We are going to have many others webinars through the year. And okay, where can you find your codes? The seismic code is I think it's easier to Google it. You can put it like Costa Rican seismic code. Let me see if I can make it faster. Um, I think this is the previous version. I'm gonna put this uh, on the general chat, and also the information about the uh, Ministry of Housing, and where you can find the what we have been watching today. I think that normally it's easier for me to find Google. You can come here, and this web page is also on the presentation. And if you come here to emergency, you will find the field guide, that is how to it has to be all the information that we have to have seen. There is complete, like, I don't remember, there were like 149 pages of information on how to make the evaluations. And also you can find here the form. This is a paper version in case something doesn't work, but it has the same question and the same weights that we have been seeing through this presentation. Thank you so much. She has added us something about seismic codes in Latin America, a YouTube link. I'm going to use it and also put it on the chat so everyone can have it. Thank you, Silma. Super, Nick, that you have in Greece something like that. It's very good. It's very nice to know that, and I think that not comparing our guides with others can help us to see if we have, for example, put so much measure in something. I think that we can always be thinking about what we're doing with this, because also the construction changes and we have also more information about earthquakes. So I think this is very good. And it's nice to see that they are watching us from Greece. Thank you, Nick. Okay. I think we stick very good to the time. For us in Costa Rica, it's 11 in the morning. I hope that I think that you are in the afternoon or maybe at 9. But thank you very much for your time. And I think that with this, we can finish our presentation. Sulma has added something that in Latin America, seismic codes are not free access. Sometimes have to be paid. This is something true. Okay. I think Carol o Charo, podemos cerrar la transmisión ya.